Good morning everyone. Today I am going to discuss Master's theorem in design and analysis of algorithm subject. So Master's theorem is used to solve the recurrence equations. Master's theorem is used to solve the recurrence relations. In our subjects, algorithms are two types: recursive algorithms, non-recursive algorithms. How to find out the time complexity for recursive algorithms and non-recursive algorithms. Non-recursive algorithms, we will compute the time complexity line by line and find out the time complexity. How to compute the recurrence algorithms? For the recursive algorithms, we need to find out the recurrence equations. We need to write the recurrence equations. So recurrence equations can be solved by two methods. First one is substitution method and second one is Master's theorem. There are two methods to solve the recurrence equations. First one is substitution method and second one is Master's theorem. So substitution, again two substitutions are there, backward substitution and forward substitution. So this is the compared to Master's theorem, it is little bit difficult compared to Master's theorem. And second one is the Master's theorem. So Master's theorem is used to solve the recurrence equations and find out the time complexity. So Master's theorem, how to find out the time complexity? First one, that the recurrence relation is in the form of T of n equal to a into T of n by b plus theta of n power k into log power pn. So the first one, the recurrence relation is in the form of T of n equal to a into T of n by b plus theta of n power k into log power pn. So what is a, b, k and p values? Here a greater than or equal to 1 and b greater than 1, k greater than or equal to 0, p is a real numbers. So these constraints we need to follow while taking the recurrence equations. For solving the recurrence equations, here using Master's theorem, three cases are there: case 1, case 2, case 3. Case 1. So first we need to compare a with b power k. We need to compare a with b power k. So if a is greater than b power k, then the formula is T of n equal to theta of n power log a base b. So this is the formula. Case 2, if a equal to b power k, here case 2 again three subcases are there: p greater than -1, p equal to -1, p less than -1. If p is greater than -1, the time complexity is T of n equal to theta of n power log a base b into log power p plus 1 into n. If p equal to -1, the time complexity T of n equal to theta of n power log a base b into log n. P less than -1, T of n equal theta of n power log a base b. So these are the three cases, subcases in case 2. Next one, case 3. If a less than b power k. So first case is a greater than b power k, second case is a equal to b power k, third case is a less than b power k. So how to get a, b values? So the given recurrence equation is compared with the Master's theorem equation, then we will get the a, b, k values, and then we need to compare a with b power k. So based on that we will need to apply the formulas, case 1, case 2, case 3. So which condition is satisfied, accordingly we will apply that formula only. Here case 3 is if a less than b power k, again two cases are there: p greater than or equal to 0, p less than 0. If p greater than or equal to 0, the formula is theta of n power k into log power pn. If p less than 0, the formula is T of n equal to order of n cube. So these are the three cases. These are the three cases and formulas. Again each case, first case subcases are not there, second case, third case subcases are there. So in Master's theorem we need to remember the formulas. Then only we will do the we will compute the time complexity. We can compute the time complexity. If you don't remember the formulas, then we cannot compute the time complexity. Compulsory we need to remember these formulas. I will explain with an example. For example, the recurrence relation is T of n equal to a into T of n by 2 plus n square. So this is the recurrence relation. This is the recurrence equation. So by observing this equation, this is the Strassen's matrix multiplication using divide and conquer strategy, the recurrence equation. So I am taking this is the example. the recurrence equation is T of n equal to A into T of n by 2 plus n square. How to compute the time complexity using Master's theorem? So what is the recurrence equation of Master's theorem? T of n equal to A into T of n by b plus theta of n power k into log power Pn. So this is the Master's theorem recurrence equation. This recurrence equation is compared with the given equation, then we will get the A, B, K, P values. So based on that we will move the next one. So by comparing these two equations, what is A value, what is B value, what is K value and what is P value. By comparing these two equations, 8 into T of n by 2, here A into T of n by 2, instead of A, what is the number here? 8, so A equal to 8. T of n by 2, T of n by b, so here b equal to 2. Next, theta of n power k, theta of n power k, theta of n square, n power k, instead of k, what is the value here? 2, k equal to 2. Here there is no log term, here there is no log term, here there is no value, there is no value means here 1. So when it will be 1, log term when it will be 1, here log power 0 only, log power 0 only, then the value becomes 1, because here log power 0 n, then only here the value become 1. So what is the value of p here? 0. So first one, the given recurrence equation is compared with the Master's theorem equation, then we will get the A, B, K, P values. So based on that, after that we need to compare A with B power K, A with B power K. In Master's theorem 3 cases are there: A equal to B power K, A greater than B power K, A less than B power K. So which case? So we need to compare A with B power K. A value is 8 here, B power K, B value is 2, K value is 2. So 8, 4, 8, 4. So what is the relation between these two? Greater than. So what is the relation? A greater than B power K. If A greater than B power K, which case? First case, A greater than B power K. What is the formula? T of n equal to theta of n power log A base B. So this is the formula. Apply the formula and substitute the values, then we will get n power log, what is A value? 8, 8 base 2. So by solving this equation, then we will get the time complex theta of n cube, theta of n cube. So we will concentrate on formulas only. First what is the process is, first the given equation is compared with the Master's theorem equation, then we will get the A, B, K, P values. After that we need to compare A with B power K, A with B power K, if greater than, less than, which one. So based on that we need to apply the formula, then we will get the time complexity. Thank you.